number, then you need to return -1. So it is very clear enough from the description, right? Like you can directly start writing the code by looking at the description, but still for the confirmation and more clarity, we can look at the input and output. Input, output, and the explanation. So he is given that A has 426, B has 486, C has 652, and the output is 6. Why? Because in A, B, and C, 6 is the only common digits. If you look here, 6 is present here, 6 is present here, 6 is present here, right? So it's the only digit that is repeating. So that is the reason 6 is the output. Okay, 6 is the output. And coming to the assumptions, as I told you, like you might think, as I told you, like you might think in different variations of the numbers of the input. So that is the reason he has given the assumptions such that to make it very much clear. So these are kind of constraints. So he's saying that all the three numbers are 3-digit numbers. So he's saying that all the three numbers will be 3-digit numbers only, and all the three numbers can have at most one. At most is nothing but 0 or 1. Okay, 0 or 1 digit common. So either there will be no common digit, or else there will be only one common digit. Okay, there will be only one common digit. So I will give you the second input regarding the -1. I think most of you might know, but still for those who don't know. So 1, 2, 3, B is 4, 5, 6, C is 7, 8, 9. Okay. So in this case, my output -1. So this is the another condition, which is given in the description. So if you look here, there is no common digit in each and every number. Here there is 1, 2, 3. There is no 1, 2, 3 in this B and C. There is 4, 5, 6. There is no 4, 5, 6 in A and C. This 7, 8, 9. There is no common digit in A and B. Got it? So this is the understanding of the question. So we understood the question, like what it is. Now we need to see how to solve this. How can we write a logic for it? Okay. Most of you are giving it right. I appreciate it. For those who are still trying, just try to observe. I'll give you 5 more minutes to crack the logic and solve. Then we'll discuss the problem. Try to do it dynamically. Try to write it dynamically. It should work for different inputs that you give. So even if you can write a pseudocode, it's also fine. But if you write a code and then test for different test cases, then it will be perfect. The output is wrong. So I think you need to change your logic if your output is wrong. So look at the code carefully and then do the required modifications. కావాలా
పాడితే ఏదో ప్రాబ్లం
So everyone mute yourself, please. So another important point that you need to keep in your mind is the given input will be in integer. Okay, the given input will be in integer. So if you are say like most of you have read it as, I mean, typecasted it to string. So that need to be done by default. They are not strings; they are integers. So 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 everyone try to put the code in compiler and check. That is the best way to check whether your code is working fine or not. So I see a few mistakes in some code. So please try to put it in the compiler and then check whether it is working or not. Okay. Okay. So just a minute. Yeah. So I hope it is clear for everyone. So I think my screen. Yeah. So so I hope everyone have understood the problem, and most of you have written the pseudocode, and most of you have also written the code very well. A few of the people have done few mistakes, so you can check now what is the mistake that you people have done. So yeah. Okay, fine. So he's saying that there is a function which is accepting 3 arguments as ABC. So you need to write your code here, right? So he's passing the function here. So let me, so he's reading this in such a way. So int of input, I told you the input variables are integers. So you need to take it as it is. So you need not, write these statements in your examination. So you need to only implement this function. So you need not worry about reading the input. So function of a comma b comma c. Okay, a comma b comma c. So now let us see. So there are 3 numbers given. Okay, 3 numbers are passed to the function. So we have the 3 numbers. So we need to find out the common digit from the 3 numbers. Okay, common digit from the 3 numbers. So it is very easy to convert these strings to these integers to strings, and then check whether each number is in the other number or not. Getting my point? So it is simple that how we are checking, like manually how we check. We see 4 to 6, we see whether 4 is in B and C. No. Then we see, well, then we check whether 2 is in B or C. No. We check whether C is in B or C. Okay. So this coding is nothing but, I mean, the logic is nothing but how you see the problem. I mean, manually we check like this. So we need to tell the computer to check in the same way, right? You need to write the code in the same way that how you are checking for the input manually. So that is the, the easiest way or the hack to crack the logic. Okay. So what you need to do first thing is, okay, let me start writing the code so that it would be easier. Okay, so we have ABC here. Okay, so for example, I will do it directly. So first we need to iterate through the A variable, right? We need to iterate, as I told you, we need to iterate through each number and check whether that number is present in B or C. Okay, B or C. So what I will be doing is I will run the for loop for let me take a number for num in A. For num in A, tell me this statement is correct or not. Okay, this is a for loop. Okay, this is a pass. Now tell me whether this statement works fine or it throws an error. Fine, error, fine, error. Why is it an error? Why it will throw an error? Perfect. Cannot iterate an integer. Perfect. Okay. So keep in your mind, that is the very important thing that you need to keep in your mind. You cannot iterate a integer. Okay. You cannot iterate an integer value. Okay. Either it should be in a list or it should be in a string to iterate it. Okay. So we need to iterate to the number, right? I mean, we are checking each and every digit. So in that case, we are iterating, right? We are iterating. So in order to iterate, we cannot iterate an integer. So what we will be doing, we will convert that integer to string. Convert that integer to string. So in this case, we can iterate. Okay, it will not throw any error. Okay, it will not throw any error. Perfect. So this is the important thing that you need to keep in your mind. Like I have seen most of you people have iterated an integer in your code. So that is the reason I told you to check that in a compiler. That is the important thing that you need to keep in mind. So I'm iterating, okay, for num in str of a. That means, okay, I will just a minute. I will try to. So that means, for example, let me take, so a is 426. Is it okay? Let me copy paste this. Okay, so now if you look at the statement, what we are doing, we need to iterate number of balls in the kth row. That is, it is the number of balls in the kth row. That means in 0th row we have one ball, in first row we have two balls, I mean in second row we have 7 balls, and in third row we have 13 balls. Okay, so every kth row of the box needs k plus 1 whole square box. That means, so I think we need to consider it from 1. So we need to consider this thing indexing from 1. Okay, in the first row it requires, no, we need to consider it from 0, because in 0th row it requires 0 plus 1 whole square balls. That means 1 square. That means 1 ball is required. In the first row it requires 1 plus 1 whole square. That is 2 square is 4. It requires 4 balls. In the third row it requires 3 plus 1 whole square. That is 4 square. And the 2 plus 1 whole square, it is second row. 2 plus 1 whole square, it is 3 square is 9. It requires 9 balls. For the third row, it requires 16 balls. So if you look at the explanation here, so the number of balls each row needs. So in the 0th row, it needs 1 ball. In the first row, it needs 4 balls. Second, 9. Third is 16. But how many we are having in the array? In the 0th row, we have 1 ball. That is fine. In the second row, we have 2. Third row, 7. Fourth row, 13. So now he's asking how many more balls are required to match the number of balls. Getting my point? Yeah, it will work. If you subtract number of balls each row needs minus number of balls each row has. Yeah, it will work fine. It will work fine. So understood the question? So for a particular row, for each row, it requires some certain balls. That is k plus 1 whole square balls. That is index plus 1 whole square balls. But at that particular index, we have these many balls. So he's asking how many more balls are required to match the total number of balls each row needs. Got my point? Understood the question? Yes. Yes. I mean, simple it is. Like if you, like most of you might not understand from the description. Okay, I will repeat it again. So in a particular row, in a particular array, he's saying that for each kth row, that means for each row in an array, he's saying that it requires k plus 1 whole square of balls. That means for example, first let us consider it as 0th index. This is first index. This is second index. This is third index. This is nothing but k values. Okay, these are k values. These are k values. So he's saying that it requires k plus 1 whole square of balls, total balls. So 0 plus 1 whole square is how much? 1. So 0th row requires 1 ball. Next, First row requires 1 plus 1 whole square, that is 4. First row requires 4 balls. Second row requires 2 plus 1 whole square, that is 3 square is 9. Second row requires 9 balls. The next, third row requires 3 plus 1 whole square, that is 4 square is 16. Okay, it requires 16 balls. But how many balls we have for each row? The given array is nothing but the number of balls in each row. So in the first row, we have 1 ball, okay, which is matching the total number of balls. In the second row, we have 2 balls, but we require 2 more here, right? We need 4 balls, but we have 2 balls. Next, 7. Okay, we have 7 balls, but how many we require? 9 balls, right? Next, 13. We have 13 balls in the row, but we require 16 balls. So he's asking how many total balls are required to match the number of balls in each row needs. Okay, that is, when you consider the first row, we don't require any ball, right? 1 is matching, so we require 0 from the first row. From the second row, we have 2 balls, but we need 4. That means 4 minus 2 is 2. So we require 2 more balls to match. Similarly here, 7, but we need 9. So how many balls we require to match it? 2 balls. Similarly, 13 here, we require 16. So 16 minus 13 is 3. So we require 3 balls here. So what is the sum of them? 2 plus 2 plus 3 is 7. So the total number of balls that we require is 7. Got it? So I'm getting the answers. Okay, fine. Understood the question now? Yes. Yeah. So now start writing the pseudocode or the code and then check. After a few minutes, I'll be writing the code and we can discuss. Okay. Okay, and looking at the code like you people have put. These are the questions which came in Accenture exam recently. So these are not the assumption questions. These are the questions that Accenture has conducted in the exam. So you people are solving the questions of Accenture. Okay, so fine. Like most of you have answered it. So please check with the other input. So let us jump on to the coding platform now. Let me clear this. There is an array. So we are reading the array. So array equals list of dot split. So I'm passing the array to the function now. Okay. Now I have array. Okay. Array saying consisting of number of balls. What we require. So let me, we require size of the array. I will tell you length of the array. So I'm finding the size of the array directly. So now what I will do is I will write the code and then explain it. Sum of I plus 1 whole square I in range of n. I will explain you each and every thing. But what is the what is the sum we have in the array? That is sum of array. So what I will do, return sum minus have sum. Maxsum minus have sum. So if you look here, what I am doing is simple. So instead of considering each row and what is it, subtracting the values like 4 minus 2 in such a way, what I'm doing is very simple. I'm just adding these. I mean 1, 4, 9, 16. What will be the value if I add 1 plus 4 plus 9 plus 16? It will be 16 plus 9 is 25, 25, 30, right? So this is the total number of balls we require from 4 rows. I mean 0, 1, 2, 3 rows. How many we have? That is sum of all these. That is 13 plus 7 is 20, 20 plus 2 is 22, 22 plus 1 is 23. So how many we have? 23. How many we have? 23. So what is the final answer? 30 minus 23 is 7. 30 minus 23 is 7. So this is the same answer as this thing. The answer is same. Right? The answer is same. So what you people are doing, I mean, even that approach is correct. Even this approach is also correct. So you people are calculating it for each and every number, right? 4 minus 2 plus 9 minus 7 plus 16 minus 13. So even that will work, but this is a simpler way. Just add these total number of balls each row needs and add total number of balls each row has, then subtract this minus this. You will get the answer. Got it? So that is the logic that I have implemented in this code. So what I am doing is this list comprehension. Like if you people know, this is the list comprehension. Like within list, I am writing the code like this. I mean, it is nothing but this code is equivalent to, let me tell you, this code is equivalent to, I will write it down. See, this code is equivalent to for I in range of n. I mean, some random, let me take a temp variable, temp equal to I plus 1 whole square. And what I'm doing is list dot append of temp. So this particular this statement is equivalent to this for loop. Okay, that statement is equivalent to this for loop. I'm not considering temp in this particular statement, but it will work like that. Okay, so what I'm doing is simple. I'm iterating the for loop. So I'm identifying the squares of each index, that is 0 plus 1 whole square, 1 plus 1 whole square, 2 plus 2 whole square, 3 plus 1 whole square. And what I'm doing is I'm appending it to the list here. So I'm appending the values to the list. So what it will be, the list will be in this way: 1, 4, 9, and 16. 1, 4, 9, and 16. So after getting the list, what I'm applying here, I'm applying the sum function, right? If you observe here, I'm applying the sum function. So if I apply sum function here, what it will return, it will add all the elements here, 1, 4, 9, and 16, right? So it will return 30. So now in the maxsum variable, we have 30 as the answer, right? 30 as the answer. Now in the have sum, we have sum of the array. Sum of the array is nothing but 1, 2, 7, and 13. So that will be added and it is taken into have sum. So what I'm doing, I'm just returning the maximum sum 30 minus have sum 23. So it will return 7, right? It will return 7. No, won't be having the more number of balls than required, because it is the the opposing case, so the test case won't be in such a way. You need not worry about it. I think it is given in the constraint. See, if you observe here, the assumption he has given it here, right? The array of k, that means the value will be less than or equal to k plus 1 whole square. Getting my point? So it will be, for example, if it is 4 here, so the array of k, that is the element will be less than or equal to k. That means 0, 1, 2, 3, 4. That's it. Okay, that is the assumption here. Got it? So there won't be more balls than required. Getting my point? So now, tell me whether my code works fine for all the test cases or not, according to the question given. So even this question is from the Accenture. So tell me whether the code works for all the test cases or not. If maxsum equal to have sum, print -1. So is it given in the I guess no. In note, it is return -1 if array is null, not equal. That means if the array is empty, okay, if the array is empty, then you need to return -1. Okay, if the array is null, return -1. So I think most of you might not implemented that particular test case, right? You have written the code only for the logic. So even you need to implement this particular test case also. If I have sum equal to 0, print -1. Okay, even that works. Or else you can do it directly. I mean, there is no need to, iterate through these statements also. You can write it directly. If n is 0, if length of the array is 0, then you can return -1. You can do it directly, or else you can do this also. If length of array is none, if length of array is none, return -1. Or else you can do it this way. N equals length of array. Got it? So even the logic which you people have written is also correct, considering the each row and subtracting the value. And I mean, this seems to be very simple, right? This seems to be very simple. I mean, within 5 minutes, you can write the code and execute it. Like most of the problems will be very easy. I mean, within 5 to 10 minutes, you can clear the question. There won't be any question in such a way that you will write a lot of lines of codes. So if you understand it, there will be a small glitch that can be, cracked. Just a simple mathematical problem. So think in an easier way. So what I'm doing, I'm taking the array as input. So I'm checking if length of the array is none. So that means if the array has no elements, then return -1. Okay. Or else what I'm doing is I'm identifying the length of the array. Okay. Because I'm using the list comprehension. So in this, what I'm doing is initially I'm finding out the square of the indexes. Right? I'm finding out the square of the indexes up to range n, and then finding out the sum of it. Then I'm finding out, returning the maximum minus half sum. That's it. So everyone mute yourself, please. So if you observe here, 1 to 7, 13, it is 7. I think it is not considering in this compiler. It is not considering a none here. It is expecting this a list of integers here. Seven, 8, 9 lines. Yes, this is the difficulty level of the Accenture. This is the questions that 7, 8, 9 lines code. So I have told, right? So this seventh statement is equivalent to for I in range of okay. So I mean list dot append of I plus 1 whole square. So this is what it does. Then after that, after completion of the for loop, it is just sum of list. So the seventh statement is equivalent to this statement, the for loop. So for each I value, I'm just finding out the I plus 1 whole square and appending it to the list. The list is here. If you observe, the list is here. Okay, the list is here. So I'm just appending the values, that is 1, 4, 9, and 16. I'm appending it. And then what I am doing after completion of the for loop, I'm doing the sum. I'm adding all the elements. Okay, I'm adding all the elements, finding out the sum and storing it in maxsum. Okay, storing it in maxsum. Then after that, we have sum, that is the sum of the array, that is 1, 2, 7, and 13, which we have. I'm just finding out the sum of the array, the total balls in the that box row. And then what I'm doing, I'm returning the total number of balls, max sum minus the number of balls that we have sum. So max sum minus have sum will return the answer that we require. No, I mean, can we solve these functions without using the function? I mean, you're talking about the inbuilt functions. Like you can do it. I mean, without using the inbuilt function, you can do it. I mean, iterate over the for loop and then add it. But if you're talking about this particular function, you can't do it because this is the default function that is given in the Accenture code. Like in this function only, you need to implement your code, this particular logic. This particular logic you need to implement in the function only.